property to factor each polynomial. We will, in fact, have a test before the end of the quarter. Remember, the end of the quarter ends next Friday. So we will, in fact, finish Chapter 8 and have a test before the end of the quarter. So notice what the directions here say to do. They say to use the distributive property to factor each polynomial. And so what we're going to do is we're going to break this down and look at individual components. So if you notice, I have how many terms here? 2. So what would I call this? A binomial. That's right. And so what I'm going to do is I'm going to look first of all at the coefficients. And I'm going to say to myself, okay, I have 27 and 18. What is the biggest number that will divide both 27 and 18 evenly? 9. So there we go. So I'm going to write a 9. Now what I'm going to do is I'm going to look at the next term in the binomial. I have a y squared and a y. What is in common with a y squared and a y? 1y, right? So then now what I'm left to do is I'm left to fill the blanks in. And so I've got a quantity here because I took out what was in common. And so now I think, okay, if I took out a 9 from 27, 9 times what is 27? 3. I had a y squared to start with in my first term. I took out a y. What am I left with? Y. Next is your plus sign. Okay, once again, I have to think, what number times 9 gives me 18? 2. I've already taken a y out, so if I take a y from a y, what am I left with? Nothing. So this is how we would use the distributive property to factor that polynomial. So let's look at the next one. I have 15w minus 3v. So once again, I'm going to start with the 15 and the 3. What is the biggest number that goes into both 15 and 3? 3. Let's look at the next terms. I have a w and a v. What's in common with a w and a v? Nothing. Okay. So now I'm going to go ahead and look at this. 3 times what gives me 15? 5. What else do you have there? A w. Yep. 5w minus 1v, or just v. Now the biggest thing, what you can do on every one of these is you could check your work, because when all is said and done, you should be able to take this answer I have here, and you should be able to go back to the problem. When I say that, what do I mean? If you have 3 times 5v minus w, or 5w minus v, sorry, I said that wrong. If I distribute that, I've got 3 times 5, which is 15w, minus 3v. And that's what I started with. Yep. All right, so let's look at this one. Ooh. So we had our warm-ups there. So now I've got 3 terms. So what would we actually call this 3-termed trinomial? So I'm going to start. I have a -4, a -8, and a 2. What will go into all of those? A 2. I could also take out a -2. It doesn't matter. Okay, so if you wanted to, I could just keep it at a 2, but I could take a negative out as well. Let's look at the next one. So I have an a squared, and an a, and an a. What is in common with all 3? An a. Very good. Let's look at the next one. B squared, b. B. Okay, so parentheses. Let's think about this. 2 times what gives me -4? -2. A times what gives me a squared? A. B times what will give me b? Nothing. Just leave it alone. So 2 goes into -8 how many times? -4. What else do you have from that term? B, because your a is already there. And then plus 2 times what gives me 2? 1. What about your a and your b? Nothing there. Now notice you still have to put the +1 because that serves as a placeholder. So if I were to go ahead and use the distributive property now, I would get exactly what I started with. Okay, I want you to try this bottom one. Okay, you try this bottom one for me. Just a sheet of scratch paper. Well, like after
Huh?
because there was no reason.
I'll be a driver's No, I heard it.
It depends on what you have. I already had a 2AB to start with, and I took out a 2AB. Okay, real quick, from what I was going around and looking, I think we need to look at things real quick here. So I have a 7, a 21, and a -1. So when I think about a number that goes into all three of those, there is none except for the number 1. Okay, so that was kind of disguised because it made you think that 7 went into those, but it really doesn't. And so then now if you break that down, you've got u squared, u, and u, so you can take out a u. You've got t squared, and t, so you can take out a t. And now what I'm left with is I'm left with thinking, okay, 1 times what is 7? Well, that's got to be 7, right? U, if I take a u from u squared, u, take a t from t squared, t. From the next one, 1 times 21 will give me 21. U from u is nothing. What's a t from t squared? T. And then minus 1. And notice here, I already had a u and a t to start with, and I took out a u and a t, which means you have nothing left but the number 1. And there you go. Okay, questions? So now we're going to look at how you factor by grouping. Okay, we're going to get into some factoring now. And so factoring by grouping, a polynomial can be factored by grouping only if all of the following conditions exist. Okay, I don't know if you need to write down this box so much as just know what is contained within it. There are 4 or more terms. So you can only group when you have 4 or more terms. The terms have common factors that can be grouped together, and there are 2 common factors that are identical or additive inverses of each other. Okay, now that's probably not going to make a whole lot of sense, so we're just going to look at an example. I think that'll make a little better sense. So you have 4qr plus 8r plus 3q plus 6. Now, generally when we group things, we group them by the first 2 and the last 2. If I look at the first 2 here, what do you notice about the numbers 4 and 8? Yeah, they have a 4 in common. Basically, the first is like double, or the second is double the first. So if I were to group these, is the second term double the first? Yeah, so that's what they're meaning when they say something's in common. So let's go ahead and look just within these 2. So I want you to disregard the 3q plus 6 for now. What is in common with the 4 and the 8?
They are divided by
What's in common with the 4 and the 8? A 4, right?
4.
Then you have, what else is in common with these 2? An r. Very good. So when I take a 4r from 4qr, what is left?
got nothing.
A q. 4 times what will give me 8? 2. And notice you already have an r there. Now what we're going to do is we're going to do that same thing with the 3q plus 6. So I have a 3q and a 6, right? What's in common with the 3 and the 6?
3.
A 3. Is anything else in common with those 2 terms?
Absolutely.
No. So let's go ahead and finish that. So if I take 3 from 3q, that's going to leave me with, take 3 from 6, 2. Okay, so here's your first term that's in common. You notice that those need to match. If they don't match, you've done something wrong. That is one of your factors, q plus 2. Can somebody guess what the other factor will be?
2.
4r
4r plus 3. So let's look at where the 4r plus 3 came from. Here's the 4r. Here's the plus 3. Okay. So the first one is what's in common. The next one is whatever is left outside of the parentheses. So we've just factored by grouping. We're going to try another one. Okay. Let's try, oops, did I skip one? I think I skipped one. There we go. Let's factor that. Rn plus 5n minus R minus 5. So if I were to group these first two, you're going to notice me group things a little different this time. How did I group things a little different
Because
versus?
you got the sign.
Yeah, in the last group, I left that plus sign out. This one I had to put the negative sign within, and you're going to see. Okay, so that negative sign is really important. We can't lose that. So let's look at the first terms. I have Rn and 5n. What is in common with those?
1.
1,
And
n. What does that leave me with? R plus 5. Okay, now in the second bunch, I've got a negative R and a negative 5.
1. Negative 1.
Okay, now let's look. I know I need to match this, right? And that one's actually a positive R. So if I take out a negative 1, what that's going to create is that's going to give me a positive R. If you take a negative 1 from negative 5, that leaves you with a positive 5. So you have to be really careful with those negatives, and you kind of have to be looking ahead. You know you need to get to this, and you did. Okay, so that's one of my factors. What is my other factor going to be? 1n minus 1, right. No, you don't need the 1. You can just put n minus 1. So I want you to try this bottom one for me. Okay, and I think we'll probably call it good after this one for today. Okay, so you try that bottom one for me. 3np plus 15p minus 4n minus 20. 3np plus 15p minus 4n minus 20. So if I take out a 3p from that first grouping, that's going to leave me with a 1n. Okay, so then I think 3 times what is 15? The answer is 5. All right, now if I have negative 4n minus 20, I can actually factor out a negative 4, in which case I get n plus 5. Yep.
Wait,
Because if you take a negative 4 from a negative 20, your answer is going to be positive 5. So you're going to notice those match, which they do. And that's what we want to have happen. So n plus 5 is a factor. The other factor will be 3p minus 4. I think we'll call that good for today. Now what I need you to do is start working on your assignment. This will be due Wednesday. Okay.
Today is Sunday.
So tomorrow we're going to pick up with it. So page 498, 16 through 44, the evens. 16 through 44, the evens.